Hello friends, this is Anand Pai from Academy in Pursuit of Engineering Excellence. Today, after GATE is over, I thought we will do some challenging questions in fluid mechanics. Okay, and also I was supported by one of my friend H.N. Manjunath. He has asked me, he has chosen a bit difficult problem for me, which tests the concepts in ballistics, continuity equation and control volume. I will show the problem now. It is here in the small one which you may not be able to see. So in case, just what you have to do after the problem comes in front of you, just read it, and if you could solve it, it would be better. It's a challenging one, and if problems are done by yourself, it is very good. Okay, so I challenge students to do this problem yourself. GATE is over, exam is over. Now go for skill development. Okay, learn something new, learn skill, learn that skill of solving problems. Okay, so let us do this problem. It is university level question. Okay, maybe it was asked in some US university. So let us see what is that. The problem is like this. I think it is clear because it was sent to me through WhatsApp, so it may be clear now. Okay, a bit here and there I will read it for you. Okay, a hose having a diameter, I'll help you out here like this. Okay, a hose having a diameter of 1.8 centimeter shoots water at an angle that is 60 degrees from the horizontal. The height of the hose exit is 2 meters above a certain platform. The jet of water reaches a maximum height of 4 meters above the platform, that is 2 meters above the hose exit, and then lands in a circular tank initially empty having a diameter of 1.2 meters which sits on the platform near the bottom of the tank, but around its curved surface are 36 identical holes, each having an area of 0.50 centimeter square, through which water leaks out horizontally and completely off the platform. What is the increase in weight supported by the platform from when the tank is empty to when the water level in the tank becomes steady? This is one of the tricky questions which really tests your concepts. Let us see what is that. Let us understand the question first. The question is understood like this. Okay. So now first of all, first step is, if you can stop here and attempt it, well and good. Now go for the next step where I will explain you the problem better. Okay, or hints I'll give you. Okay. So now what happens here is there is a platform like this. I will draw it horizontal, just a second. So there is a platform, horizontal platform like this, and there is a hose which is at 60 degree angle, correct? So it is at 60 degree angle here, and it is shooting water, okay, out of this, and this water goes to a maximum height of 4 meters above this platform level. Okay, this goes to 4 meter height, and this water where it is exiting, it has a height of 2 meters. Fine. Next, it lands on another cylindrical vessel. It is landing on a cylindrical vessel of diameter 1.2 meters. Of diameter 1.2 meter. But the cylindrical vessel unfortunately has 36 holes all around like this. There are 36 holes all around, each one having 0.5 centimeter square area. So whatever you are filling in is going out. Okay, I don't know, we will see that. Okay, so it is not the height, whatever is increasing has to be steady. Steady means whatever is coming in like this has to go out from here. Now, how to solve this problem? This problem has, first step is to solve a ballistic problem, to find out U. This is a hint I am giving you. U. Okay. Once you find out the U, then next what you have to find out is, you have to find what is the height to which it attains. What is the height it attains? So the height into the volume, the height into area into volume into density into the gravity gives us the weight of this liquid column. That is one thing we have to see. Second thing we have to see is the velocity is going out here. See, there's a control volume here. So what is happening? The water in this control volume is going in like this inside and coming out here. So when water is going in and coming out, there has to be some weight. There has to be some force. Is it not? That force also has to be calculated. So let us see what is the how we have to calculate these. Okay. So stop here. If you can do it by yourself, do it now. Okay, I've given you the hint. I've explained you the formula. So if you can do it at this moment of time, please try it. Okay, and tell me in the comments that you have done it in the second attempt. First attempt is just seeing the problem you are able to solve. Second is when you will be able to, when the hint is given, after the second step, okay, you are going to do it. That is second level. The third level, let us explain that. Okay. So now let us do the ballistic problem first. So now the ballistic problem is, it is the hose is here, correct, and it is coming out like this. Okay, so it is at 2 meter height. Fine. This is velocity u. So now always there are in school level or this one, there are equations which are there, but now we will go with a differential equation approach. What is that? It's simple, that my d square y by dt square means if I consider this as y and this as x, correct, u is along some direction here. Okay, so d square y by dt square is actually equal to minus g, because that is the acceleration due to gravity. So d square y by dt square is minus g. That means my dy by dt is equal to minus gt plus a constant. Now what is that constant? That constant I put it at C1. What is that constant? At t is equal to 0. That means when it is going here, what is the dy by dt? How the y is increasing? It is increasing. Here you should have a theta. We know this is 60. So if this is 60, then this should be 30. Correct? So now we can have at t is equal to 0, dy by dt is equal to, I can say these are the boundary conditions I am putting. So at dy at t is equal to 0, dy by dt is equal to u cos 30. Correct? U is the velocity with which it is coming out. So u cos 30 is the velocity with which it is coming out. Now if that is the case, then my C1, applying this here, we get C1 is equal to u cos 30. That means my velocity becomes dy by dt, vertical velocity, dy by dt is equal to minus gt plus u cos 30. Correct? Next, after this point, okay, we will integrate again. When we integrating again, this I will say it as equation number 1. Okay, let us integrate. It's a long question, I do agree, but long question only tests your knowledge better, it will test your character also. Integrate. Now when you integrate this, y is equal to minus gt square by 2 plus u cos 30 into t plus another one C2. Now how to find out C2? At t is equal to 0, y is equal to 2, this implies my C2 is also equal to 2, because this goes to 0, this goes to 0, C2 becomes equal to 2. So now that means my equation, what I am getting is for y is minus gt square by 2 plus u cos 30 into t plus 2. This is equation 2. Now till here, if you have done it by yourself, you are in the position 2. Now after this, if you can solve after this, then in the third stage you are there. Okay, see whether you will get third grade. That is, first grade is just by seeing the question. Second grade is if you after I explain you the problem, you are able to solve. You are in the second grade. Okay, at the second class. Third class is after this. Okay, after this you are not able to solve. Okay, you need my help, then you are in the third class. Okay, so keep in mind. So go step by step. I am just giving you Not that you are in the third class, but I am giving you a ways by which you can do it. Okay, so let us see this. Okay, now if you are not able to solve over here, then go for the third step. Now the third step we will see. Third step is got by saying y max. When does y max happen? Y max is when dy by dx is equal to 0. Dy by dt is equal to 0. That is, change in the height doesn't change with time. That is the case here at the top. Okay, over here dy by dt is equal to 0. So dy by dt, if I equate to 0, I will get it. That means I have to equate 1 to 0. Okay, so let us do that. So what is the equation 1 I am having? Equation 1 I am having is minus gt plus u cos 30 is equal to 0. This implies my time is equal to u cos 30 divided by g. Put this as equation number 3. And this 3 we can substitute in equation number 1. So substitute 3 in 1. Now after you substitute 3 in 1, next what you will get? You will get this something like this. Okay, so when you substitute that, y max, wherever y is there, you are putting y max is equal to, which is equal to 4, right? 4 meter it reaches at the top. So minus gt square by 2 is there. So g by 2 into t square is u cos 30 divided by g the whole square, plus we have u cos 30 into time. Ut is that, your time is u cos 30 by g. Okay, plus the constant 2. Correct. Now from this, when we solve, I got my u as 7.233 meters per second. I may be wrong, my calculations may be wrong, I am just telling you the ways. Now from this, q, that is the discharge through that pipe, discharge, q is actually equal to area into velocity. That means my q is equal to, area is pi by 4 into 1.8 into 10 power minus 2, that is 1.8 centimeter hose is given, square, into velocity 7.233 meters per second. So the q I am getting, I may be wrong, I will reiterate again, I do simple silly mistakes sometimes, okay, but this is what is the answer I am getting, 1.84 into 10 power minus 3 meter cube per second, or this is almost similar to 1.84 liters per second. So fast enough. Correct? Done. Now the first part is done. We have found what is the discharge. Now this discharge now is going and hitting that pipe, the container. Okay, it's going inside the container. Okay, and this container has 32 small holes. Correct? So not 32, 36 small holes. So when we have 36 small holes here, now what is happening? The velocity with which this is going out, the velocity with which the water is going out is proportional to h. Correct? Because velocity out is equal to root of 2gh. Correct? Now the q which is going inside, if it is equal to the q which is going out, my h is stable. Correct? The h remains stable. So let us do that. So q outflow through those 36 holes, if it is equal to root of 2gh, which is the velocity, into the area, which is this, okay, then it is sufficient. So what is that? This would be equal to square root of 2gh into 36 into 36 holes are there, and then 0.5 into 10 power minus 2. so many meters square, correct? Because centimeter square 0.5 into 10 power minus centimeter square 10 power minus 4, I'm very sorry, okay? So it is 0.5 into 10 power minus 4 is the area of that. Now doing this, okay, Q outflow is how much? It is given 1.84 into 10 power minus 3. Now solving this, I got height is equal to 5.125 meters. So this is the height to which the water will be there, okay? Now because of this height, there is a weight which is there. What is that weight? The weight is, don't think weight is the only thing, there is additional one. Do not rush into it, do not close the video because there is still more things here, okay? So the weight, what comes here, W is equal to rho G H into A. So rho G is 9810, I can say. Height is 5.125 meters into area is pi by 4 into 1.2 the whole square, because 1.2 is given as the diameter. Let me check again. Yes. If I see what is the diameter here, it empties a diameter. Diameter is 1.2. This is one of the things we have to see again, whether it is diameter given or radius. So it is diameter, so no problem. So this is equal to what weight I got was 56861 Newton or 56.861 kilonewton is the weight. So this is the first part. Second, is this the only force that we are experiencing? No. If I take the control volume over here, okay, inside this, okay, if I take the control volume inside, now what is happening? With some velocity is coming in and some velocity is going out. So should we not take the take the force because of that, which adds to the weight? Let us do that. Let us see what is the answer. So force is equal to, I can say, M1 V1 minus M2 V2. If I say that is the force exerted on this in this direction. Now if you take that, the velocity is going tangential. The velocity exit V2 will be in the tangential direction, so we need not worry. So this goes out to 0. What is M1 V1? M1 is rho into Q, correct? Density into mass flow rate into velocity. What is velocity? V1. So this comes out to be rho into Q. We have got it as 1.84 liters per second, correct? So into velocity of this one was given as 7.233. So this comes out to be 130 point. I'm taking this rho as 1000. I'm sorry, I missed that. So if I take 1000 here, I'm getting 130.55 Newton. This is the additional force because of that water coming and hitting that cylinder. But that is negligible compared to this. If we had neglected this, then also there was no problem. Okay. But the total weight is this W, total weight W. Now total weight W now would be 56861 plus 130. So it would be around 19965. Almost 60 kilonewton would be the weight. Okay. So I hope you understood this, students. If you have any challenging type of questions like this, put it on the comments. Follow my Facebook page, which I am giving here. You can directly message me the problem on the Facebook page, or you can directly WhatsApp me also, because my WhatsApp link is given on my Facebook page. You can go there and go to that link and you can tell me any problems which you feel it is challenging in fluid mechanics, thermodynamics, heat transfer. You can give it to me. Also in strength of materials. Okay. All these things, if there is some problems, you can put it. I will post a video on YouTube explaining those problems. Thank you very much, students, and kindly subscribe my channel and click that bell icon. Okay, and share it with your friends so that maximum people can take help from me. Okay, thank you very much, students. All the best.